Okay, so software reuse, unit 1. Let me just take you through the introduction. So software reuse can be defined as a process of using an existing system, component, object, or function to develop a new system. Okay, so by now, in general, you should be able to at least remember the fundamental concept of software reuse. Okay, so it's important to acknowledge that the software, the software that we built in the previous years was not as sophisticated as the software that we build in this modern era. So if you're going to start and build every component from scratch, it's going to take you a very long time, because remember, you also have to go through that whole process of Q&A, quality checking, and so forth. So by the time you go through all of these iterations, it's going to take up so much of your time. So software reuse has sort of emerged as a, for the lack of a better term, as a method of taking shortcuts while building software. But it's good shortcuts. It's when somebody talks about cutting corners, most of the time you think that quality is going to be compromised. But I feel like it's a good way of doing it, because remember, these shortcuts that we take have already been tried and tested somewhere else. So they've been proven to work. Okay. So on the second point, increased demand and prolonged time to develop a software has led to most organizations to adopt the idea of reusing software. That's one of the challenges that you're faced with, okay? The customer tells you they want the product, they want the product now. So that's your biggest challenge, and that's how software reuse can sort of come to your benefit. So the reused software is reliable, since it would have been tried and tested, cost effective than developing the whole system. So these are the following learning outcomes we'll be covering today. Have a thorough understanding of the benefits and problems of reusing software during systems development. Have a comprehensive understanding of the application framework as a set of reusable objects, and how the application framework can be used during application development. Have knowledge of software product lines, which consist of common core architecture and reusable components which are configured for each version of the product. Apply and formulate how systems can be developed by configuring and integrating commercially off-the-shelf application software systems. Okay, so just to backtrack, then what is software? So we say computer software is any set of machine-readable instructions that direct a computer's processes to perform specific operations. So software, as we know it, is a generic term. It can refer to all computer instructions. It is inclusive to both machine instructions and source code. And we know that we can further divide software into two main categories, which is system software, and we also have application software. And if we talk about system software, talking about our operating systems and our utilities and such as antiviruses and Windows. And application software is all the software that you use to perform tasks such as Microsoft Word and PowerPoint. So what is then software reuse? So another term for software reuse is, we tend to refer to it as code reuse, but it's not really a code reuse wouldn't be a good term to use, because remember, there's different levels of the actual reuse, software reuse. We mentioned this before at the different levels, and code reuse is just one of the levels. Okay, it's just one of the smallest types of reuse that you can do. So we tend to refer to it as code reuse, because that's basically what you are doing. Even if you are doing systems reuse at the highest level, it's essentially you are reusing the code of that's made, the system is made up of, and can be described as the use of existing software to build new software for an individual or an organization, okay? And software engineering has been more focused on original development, but it is now recognized that to achieve better software more quickly and at lower cost, we need to adopt a design process that is based on systematic software reuse. So software engineering typically, as they're saying, it was based on original development. Everybody wanted to be original, okay? Everybody just wanted to, say, I built this thing by myself from ground up. But you're going to be faced with big challenges with modern software if you want to do everything yourself. There are options out there for you of reusing or using particular frameworks to help you get there faster. So what would be the benefits associated with doing software reuse? Well, the first one, it is cost effective. Okay, development cost are reduced since software reuse lowers the scope of work for the project. So you reduce cost. Remember the project triangle. When you reduce the scope, also the costs of building the software and the time will be reduced. So for the mere fact that you're not going to be building some of these components yourself means that you are saving costs now. It saves time. Okay, here's the other component of the project triangle. It produces high quality products. This goes back to what I said about these components have been developed, they've been used in other softwares, which means they have been tried and tested, and hence they definitely of a better quality than something that you just built from scratch. And it also ensures that you, to some extent, you become compliant in terms of standards, because if a component is of high quality, then if it's been tried and tested, it means it's also been tried and tested in terms of the standards compliance organizations. What are some of the disadvantages of doing software reuse? Because I mean, it can't all be that good. So lack of innovation is one of them, because now what will happen is that the developers no longer become creative. Okay, to some extent you can associate it with they're going to tend to be slacking or be lazy. Remember, when you're building something from scratch, you have room to innovate. Okay, you tested, your abilities is tested to the maximum. Now if you're just taking something that's already been done by someone else and you integrate, anybody can do that. Okay, so it takes away that ability of a developer to innovate. Maintenance is costly. Okay, if you are reusing something or a particular component or element of the software, maintenance can be costly then, because you're going to need to either get support from the organization that actually built that particular component. Okay, so as time goes by, or you need to get people in the organization, or you need to hire additional people who are experts at integrating those particular components. So in terms of maintenance, it can get very costly, because you need to make use of some sort of, to some extent, a third party to do the maintenance for you. Lack of tool support. These computer-aided systems, engineering tool sets were not built for integrating components. They were built for original development. So you are drawing your systems and modeling your systems using this particular software, but there's no particular software powered by Case that you can actually use to support your software reuse. Okay, so that's one of the tricks and disadvantages of software reuse. So just to reflect again, the types of software reuse that we once spoke about in the first semester. So we have, at the highest level, system reuse. Okay, so complete systems with several applications may be reused. So this is like saying systems of systems. We are reusing the whole ecosystem. Okay. Then we have application reuse, which means a particular single application, okay? And we may be incorporating that application to our own existing ecosystem, okay? And then we also have components reuse. Components from subsystems to single objects may be reused. Component is like a form, a particular form of a software, okay? And we're reusing that particular form, be it the login form or the registration form, but that's the component, okay? And then we also have object and function reuse, and this is also can be referred to as the actual code reuse, okay? Because most of the time we'll be copying and pasting the code that actually controls the functionality for that object. So smallest units you can ever get, an example of this is maybe we're reusing code that controls what happens when a button is clicked. Okay, that's object reuse. So some of the things that you take into consideration when you want to do software reuse, okay, you think about what time or schedule am I given, okay, to actually produce the software. You're thinking about the lifetime of the software. For how many years will this software be supported in the organization? What is the experience of the development team? Okay, because remember, you're going to be sourcing these components from different directions or different organizations. Do we have people who are experienced in actually integrating components? How critical is the software? Because if it is actually mission critical, then you may actually need to consider software reuse because the standards are there and they've been tried and tested. So for example, if you're working on an e-commerce project and now you want to implement the checkout feature, it will be recommended that you reuse an existing payment gateway instead of trying to build your own one. Because you can imagine in the process of building your own one, you may leave room for errors and stuff like that. And then it becomes a vulnerability. So the mere fact that there's already an existing one that you can integrate into your software, good, just go with that one. What is the application domain? What is the problem that you're faced with? Okay, most likely you don't even have to do reuse if a particular application domain, the software already exists out there as a commercially off the shelf. The platform of the particular software that you are building for, you definitely need to ask this question so that you source the correct or compatible components to reuse, okay? You can't source components that are built for Java or Linux systems on a .NET framework. So some of the approaches that we can take for software reuse, okay? We have application frameworks, which we talk about in the later slide. Application framework is basically most likely web-based and collection of objects that you can reuse. And application systems integration, where you're integrating more than one application together and you're building a new system. Or you can go with architectural patterns. Remember, when we talk about architectural patterns and reusing architectural patterns, we're basically talking about reusing knowledge about the software, not the actual code, but the actual knowledge. And aspect-oriented software development says shared components are woven into an application at different places when the program is compiled. So this kind of reuse only happens at runtime once the software is being compiled. Then we have components-based software engineering, which it involves reusing components or integrating components that are compatible. And this components-based software engineering is a separate chapter and a study unit altogether. So when we on that particular study unit, we're going to elaborate more on it. But for now, all you need to know is it's integrating these components together. And also configurable application systems, domain-specific systems are designed so that they can be configured to the needs of specific systems customers, okay? So this is reusing a particular package that is built for a particular application domain, okay? We know there's existing applications for banks. You just need to outsource them. There's already existing systems out there for hospitals and so forth. And design patterns, this involves reuse of abstract models, or more on the functionality side, okay? Actually more on the design side than the functionality side. So all your UML, interaction models, domain models, use case diagrams, and so forth. So it's reusing those particular abstract drawings of a system. Then we have ERP systems. So with ERP systems, they basically they standardize all your features and functionality and the data of your existing systems in your organizations, okay? And legacy systems wrapping is also another approach. And this involves taking, I think we also mentioned legacy systems in the previous study that we did first semester. So it's taking an existing system in the organization and improving it, making it better, okay? So we're reusing an existing system, an old legacy system, but we're just creating interfaces for it to be linked to our new modern systems that we're developing. And also the next concept is model-driven engineering, which also is something that we discussed in the first semester. And here we say it's the ability to separate the design part, the user interface design part of the software, to the part that defines the functionality, how the system would work, okay? So all your functional and non-functional requirements and your models, okay, your design models will be independent of the platform that you're actually designing on. And with model-driven engineering, it allows for reuse, because you can just take the functionality alone and reuse it without being worried about the other domain layers. And then also program generators, and these are just programs that generate code for us, okay? They make use of existing programs that have been written, and they make it easier for us to build certain components, okay? So it's actually reusing code because it's generating the code for us. And also there's program libraries and service-oriented systems and software product lines, which we're going to be talking about in the later slide, and systems of systems. And we mentioned that it's reusing systems as a whole, okay? So application framework. Application frameworks are collections of abstracts, okay, and concrete classes that are adapted to create other application systems. These frameworks usually consist of predefined UI components, and software engineers just have to code the functionality. Well, if you've done, I'm sure you guys did web development in your second year, and you may be familiar with JavaScript. So jQuery is one example of an application framework, and it's a JavaScript-based application framework. And what happens is you don't have to spend a lot of time focusing on writing JavaScript code to build certain functionality for your website. You can just integrate these jQuery libraries or framework, or this framework, into your project, and then you basically call it or trigger it at runtime, and then it'll work. Let's say you wanted to build a gallery, okay? A gallery with images that are sliding on your particular website. If you want to build that using JavaScript and you want to build it yourself from scratch, it's going to take you a long time to code, and you want to write a lot of lines of code to actually make that gallery perform the task that you wanted to perform. So with jQuery, there's already a jQuery code. We refer to them as plugins because it's more of a plug and play kind of thing. So you just download this framework, plug it into your website, and it already comes with those functionalities. All you have to do is link it to the particular component on your website, and there you go, you have the functionality already. So you can see how application frameworks tend to save us time, and you can get them for different platforms, not just for websites only, but also for Windows Forms. There are already existing application frameworks there for you when you're building Windows Forms application, even for Android apps and iOS apps. There are application frameworks such as Material Design, where the components are already built for you, and you just need to define this particular functionality. And moving on to the next concept, which is software product lines. So considering application frameworks work with reusing particular UI components, software product lines it's basically a family of softwares that share the same core functionality. Okay, in actual fact, product lines exist in most industries. If you look at your phones, we have the iPhone 7, we have the iPhone 8, we have the iPhone 10, for example. It's still an iPhone. The iPhone 8, okay, would share the same core, it belongs to the same family, so it will share the same core architecture, okay? And the same thing applies when it comes to software. If you take Windows 8, okay, Windows 8, Windows 7, still the same family, but what is different? They added additional features. So in terms of software, we do that. We take the earlier version of the software, and we tend to think, what can we add to make this software better? As soon as we've concluded the particular features we want to add, it then becomes a new product line of the software. So in terms of Windows, if you're looking at it in terms of Windows, it's a good example of software reuse, because when they're going from Windows 7, or when they went from Windows 7 to Windows 8, they did not start from scratch, building Windows 8 from scratch. They reused the code from Windows 7. Yes, here and there they changed the user interface, but they also included additional features, okay? So I would look at software product lines as more on the application reuse landscape, and the application frameworks as more on the component reuse landscape. Then you also have software product specialization. So if we're talking about being platform specific, different versions of the application are developed for different platforms, okay? So you want a different version for Android, you want a different version for iOS. Environment specialization involves your software being able to, regardless of which platform the other person is on, it's still your particular software, so they should be able to communicate, okay? It doesn't matter if the person has WhatsApp on an Android or WhatsApp on a BlackBerry. The two people that are chatting are still able to exchange messages or communicate, and that's the difference between environmental specialization and platform specialization. And functional specialization, different versions of the application are created for customers with different requirements. And then you also have process specialization, different versions of the application are created to support different business processes. So what is the main difference between a software product line and application framework? Okay, so the first one is application frameworks use object-oriented features such as inheritance and polymorphism to implement an application, and the code cannot be modified. And if you can modify, you'll be limited in what you can do with the code. Whereas software product line components can be changed, deleted, or even rewritten. Okay, most of the time, application frameworks are plug and play, and there's not much of a need for change. Okay, you just take this thing, you download it, and you plug it into your software, and you link it to other key components. Okay, when it comes to software product lines, remember you're adding additional features, so there's certain things that are going to be changed. There's certain things you may not like about the earlier version that you may want to remove altogether, or certain components that need to be rewritten. Application frameworks offer generic support, whereas software product lines are domain specifics, since they embed domain and platform details. Okay, another way to look at it is application frameworks are more on built on web technologies or HTTP technologies or frameworks, which means any device that can communicate over the internet can actually operate that particular or execute those particular application frameworks. But software product lines are specific to a particular domain, a particular platform, as the example I made with Windows, okay? And then application frameworks are service orientated. That is, they don't include hardware interaction components, whereas software product lines control applications and environments, okay? If you picture Windows as a software product line, it controls applications, it controls hardware as well. It's an operating system. But application frameworks are merely, they're just there as visitors, and they don't have the ability to control what happens to hardware and other components and so forth. And software product lines use generic core application, whereas an application framework don't use generic core application. That is, you start by creating the closest member in the application family. Okay. And then application systems reuse basically is the term we tend to tend to refer to it as commercially off-the-shelf systems. So an application systems product is a software which can adapt to the needs of different customers. In other words, it is a generic system, and this should be done without changing the source code. Okay, so it's commercially off the shelf. You don't change anything. Examples of such is Microsoft Office. Okay, you buy it, you use it. Microsoft is in charge of it. You don't change anything. Sage, Payroll, Adobe Reader, and all of these Adobe products, and also SAP. Okay, these are commercially off the shelf. You just need to buy a license. So in conclusion, the study unit gives detailed information of how systems components, objects, functionality may be reused. Reusing software has its own benefits and problems associated with it. And then some of the benefits are low cost, the lower risk associated with the development, and a system can be implemented within a short period of time. Okay, so that is the first study unit that we're going to cover for software engineering 1B, which is software reuse. Okay, so I'm just going to stop sharing and stop the recording.